Mauritius, but you are not part of the scientific community, you might be thinking that there is nothing really interesting taking place in the science world. However, this is not really the case, and through the PLASMAT program, we will help you discover this wonderful world of science and the work of scientists in Mauritius. In the previous program, you had discovered some of the pioneering work of some astrophysicists in Mauritius in the domain of radio astronomy. Today, we'll take it further, and you will discover some of the current research being done in astronomy. If you are a young person really passionate about space, but you're thinking that this might not really be a career choice for you in this country, I will ask you to think again. Today's program will focus on current research and job prospects in astronomy in Mauritius. Before looking at research being done in astronomy, let us ask ourselves why? Why is there such a huge endeavor into looking into space? Why such massive investment in terms of resources and human power being invested into space exploration? Mr. Akbar of the Mauritius Astronomical Society has some answers for us.
It's very exciting to see that we are living in a new space age. That new space age is one which is prompted first by technology. The technology is allowing us to send machines which are smaller, which are more technology advanced, and for a longer time out there. But it's also an economic imperative. We are living at a moment where sustainable development, with the Sustainable Development Goals of the UN, which are for 2030, but we should not stop at 2030. We should go beyond. We should go in 100 years, in 200 years, where we are going to be short of our natural resources for global development, for humanity's development. So all these countries are doing that first for an economic imperative, because it's very important to understand and do the research to try to discover what is out there. USA, Russia, India, China, Israel, and many other countries are now sending new machines in space in order to be able to understand for themselves what is going to happen in terms of tomorrow and what are the new areas of energy that we will be able to exploit and use, which are going to make people better and people continue to live at the state of development and not have humanity come back in a dark age where touch wood that we will not be having any energy to survive and any energy to live. So I think it's something, first, science, humanity's curiosity, and then third, the idea of having economic imperatives, discovering what is out there, and hopefully being able to mine or use those resources which are out there peacefully.
Dr. Samana was one of the brains behind the conception, building and use of the Mauritius Radio Telescope some 30 years back. How has the country and the world benefited from his and his team's work? And what are some current exciting projects in which he is currently involved in? Let us hear from Dr. Samana.
First, we have to understand astronomy is about studying the universe. How was the universe created? How were stars created? How galaxies were created? How they evolve with time? Now, to be able to get a comprehensive picture, we need data from all the telescopes in the world. We need data from gamma-ray telescopes, X-ray telescopes, ultraviolet, visible, infrared, millimeter, and radio telescopes. It's like a jigsaw puzzle. Each telescope will bring its contribution. Some will be a bigger piece in the jigsaw puzzle, some will be a smaller piece. So the MRT project is like a small piece of the jigsaw puzzle. Even a piece can be very small, but without that small piece, we cannot solve the puzzle. So in that way, MRT has contributed to the scientific knowledge in the field of astronomy and astrophysics. So what we have done concretely is we have made a radio map of the southern sky at 150 megahertz, which has never been done before. We have detected many new objects, many new galactic objects, many new extragalactic objects. So this has never been done before. And for that matter, we got a decoration from the NASA for that achievement. And this achievement is recognized in the community of astronomers. And that's also one of the reasons why Mauritius was included in the SK project. Mauritius was included in the SK project because there's already an expertise in Mauritius, engineers, technicians, and scientists in Mauritius who have already worked in radio astronomy, who are familiar with all the nitty-gritty things about radio astronomy. So we have positioned ourselves to be in the SK project in Africa, and we have a lot more to contribute. The Square Kilometer Array project, the idea started some 20 years back. I was fortunate to be part of the African team. We have different sources of funding for constructing telescopes. So different directors of those sources of funding met, they talked to each other, they said that why do we finance different telescopes? Why don't we pool together all the financial resources and construct the most powerful telescope in the world? And all of them agreed. So there was an international bid. You had US, China, Africa, Australia, Europe. They competed for the bid. There were many criteria. The geographic position also was important. So finally, 2 countries were shortlisted. So initially it was South Africa, but South Africa realized it could not be part of this bid alone. So 8 other countries, including Mauritius, formed part of that bid. So only Australia and Africa were left. And the international group of astronomers, they decided that the SK project is going to be shared between Australia and Africa. Slightly more than 50% of the project has come to Africa, and 50% has gone to Australia. There are some 10 Mauritian students, my ex-students, who did their BSc physics with me, who have gone to South Africa to do their PhD. 3 of them have completed their PhDs, 7 will be completing very soon. And there are a few students from the Faculty of Engineering at the University of Mauritius who are doing their PhD also. Hopefully, this Mauritian team will be present in Mauritius when the SK project will start in Mauritius. This will be a new dimension to scientific and engineering research in Mauritius. Mauritius will benefit a lot from this project due to the spin-offs on the engineering and ICT side.
Research work in the domain of astronomy has been ongoing at the University of Mauritius since the past few decades. A lot of data has been captured by the Mauritius Radio Telescope, but now the plan is to innovate and expand. Dr. Issa and some of her doctoral students tell us about how they have been using the Mauritius Radio Telescope to capture data and some of their future plans.
The Square Kilometer Array project, most of it is being built currently in South Africa, and Mauritius is one of the 8 partner countries, along with some 7 other African countries. Compared to all these other African countries, it's only in Mauritius that we were in radio astronomy activity since so long, more than 30 years now. And in the UK, the Leeds University, one professor, Melvin Ware, he applied for a funding, big funding, to make sure that people in all these African countries do not become mere spectators of that big project, that they will be participating fully, scientifically, technically. The project is called DARA. DARA stands for Development in Africa through Radio Astronomy. Why? Because radio astronomy is so multidisciplinary, involving things like electronics, technical, even the data handling, big data handling. There are really very diverse fields which are involved in radio astronomy, so not just the scientific goal. And when somebody, a country, people in a country, they get equipped for that, they become empowered to transmit that knowledge to others in their country, and thereby that will help in the development of the country. So that's why development in Africa with radio astronomy. So right now in Mauritius, because we already had radio astronomy background for 30 years, so the UK Leeds University has entered into a collaboration with the University of Mauritius So that we are going to host research students in the field of radio astronomy. We have got a very good scholarship for these people. So we have 4 students from different countries like Ghana, Kenya, Madagascar and Mozambique. They're working in different fields of radio astronomy, as well as 2 local students from University of Mauritius. They graduated from University of Mauritius. But all 6 of them are working as a team to make something new here, to look at some new exciting field, which is looking at objects that come and go in the sky, along with co-supervisors from countries like the US, South Africa, UK, and India. So we have collaborations, and the students are not going to be just in this small island, like as if no exposure to what is happening outside. They are going to be working to make something great here, but we are in collaboration with others elsewhere.
My field of study is SETI, which stands for Search for Extraterrestrial Intelligence. So the aim of the SETI is to look for aliens, actually, look for intelligent sign of life into the sky. So we do that by looking for radio signals, which can tell us if there's some kind of creatures out there which have also intelligence. The first thing I will do, I will just look for exoplanets, which are in the habitable zone. It means that these planets are not too close to the sun or to their host star, or they are not too far from the host star, because they will be cold. So that's why we are looking for exoplanets that have conditions to host life. So my MPhil basically will take 2 years, but I can upgrade it. It will depend in my process in terms of developing my techniques to analyze those signals. But it will be 2 or 3 years to complete my MPhil PhD. I am from Mozambique, and especially in Maputo. And I would like to, when I go home, I help others to achieve their dreams in terms of studying. And I will be very, very great if I can help the country in terms of science and developing new techniques to approach this kind of fields, especially astronomy.
The field of study, that is the MPhil PhD. My basic goal is to set up small parabolic dish antennas for various astronomy observations, and specifically for my other colleague students who will be looking for other sources, especially the SETI and other ones. So mine is to make sure that I set up this very dish for them to be able to do their observation. My quest for choosing this particular field is my experience with Ghana Radio Astronomy Observatory, where I happen to work with the SKA team, or the engineering team, building that particular 32-meter dish telescope. From there, I have really have the quest for engineering work, especially instrumentation, to get the goals of the astronomers fulfilled.
I will be studying MPhil PhD in setting up an array of small parabolic antennas, but the focus of my work will be on working on the receiver. So basically I'll take signals from different small parabolic telescope, and I'm going to multiply them in what we call a correlator and record them using a receiver. So my work will be on the back-end systems that will be situated somewhere in the lab. The skills I will acquire here will be very important for my country, because they are part of the partner countries of the SKA, and they will be looking to construct maybe some of these dishes back home. So I will take some of these skills back home. And astronomy is also an interesting field. There are types of questions that keep me awake up at night, and this is the field where I can answer some of those questions. So I'm very excited to be here, and I hope I can take something back home when I do.
You might have heard of the Kiba Cube or the nanosatellite Measat-1, the first Mauritian satellite conceived, built and being prepared for launch by Mauritian engineers at the Mauritius Research and Innovation Council. Mr. Shamut Ali, researcher at the MRIC, tells us about the potential benefits of having the first ever Mauritian satellite in space.
The first Mauritian satellite is a 1U CubeSat, which is of the size of about 10 centimeter cube with a maximum mass of 1.3 kilograms. So this CubeSat standard has been designed for building smaller satellites that makes it more cheaper and affordable to put on orbit. The satellite will be deployed at an orbit of about 410 kilometers above the surface of the Earth, which is about the same altitude of the International Space Station. The inclination will be similar to the International Space Station, which is about 51.6 degrees. A 1U CubeSat, such as the Mauritian satellite, at an altitude of 410 kilometers is expected to have a lifetime between 1 to 2 years in space. The lifetime of satellite depends on many factors. For example, we have the atmospheric drag, the gravitational pull, and the solar radiation pressure. The solar radiation pressure is a significant factor that affects the life of a satellite and is highly dependent on solar activities. After 2 years or 3 years, the satellite will automatically descend towards the Earth and will eventually disintegrate into the atmosphere. So this meets the criteria that has been set by the United Nations Office of Outer Space Affairs that a satellite cannot be in space for more than 25 years. After the satellite has been disintegrated into the atmosphere, we are planning to continue this project, make it more sustainable. We are looking into sending a much bigger satellite for Mauritius. In order to operate the first Mauritian satellite, we'll have a ground control station in Mauritius. And we are currently developing that a state-of-the-art ground control room, which includes a missions lab in a clean room that will enable us to design future space missions for Mauritius, as well as testing new CubeSat components. We at the Mauritius Research and Innovation Council, together with the Ministry of Technology, Communication and Innovation, are striving to create a new economic pillar in the space sector for Mauritius and eventually create more jobs. Now, through this project, we'll acquire the knowledge and the skills in the space sector, and why not potentially creating a Mauritian Space Agency in the future.
I've chosen the sky because I'm passionate about the stars, the planets, the universe in itself, to know what lies beyond our space, what we cannot see, to search for extraterrestrial intelligence if we have any. And normally, right now, my field of study is about satellite communication. I will be doing a project on the Measat-1, our first Mauritian satellite that will be launched. I will be working on a ground station that can communicate with it. Normally, we've been doing radio astronomy in this area for about 30 years, but satellite communication exists worldwide since more than 50 years, but we don't have it actually, our own systems, our own satellites in Mauritius. So we are starting with Measat-1. We'll learn from it, we'll have a lot of experience, and we'll develop technologies that will make us have better plans for the future for Mauritius. For the time being, whatever satellite communication technologies that Mauritius uses, we buy it from other countries. We have service providers from other countries, and it's normally not free. We need to buy those data. But if we have our own satellite, we'll have our own data. Firstly, maybe to do communication, our international communication, or maybe inter-island communication between Mauritius, Rodrigues, Réunion, etc. And also we'll have the possibility to take data like ocean temperatures, land surface temperatures, and then do predictions to predict what will happen in the next years. Like we are having the events like flash floods and thunderstorms recently, and it's not being predicted very properly. So with satellite communication, we'll be able to gather data and make better predictions.
The geographical position of Mauritius in the Indian Ocean has attracted some international attention. We have met with Dr. Carlo Viberti, astronomer and president of Spaceland, a company that is specialized in microgravity flights and research. Dr. Viberti tells us what this is all about and some of his plans for Mauritius.
I worked 10 years at the European Space Agency, and I was coordinating for the astronaut office the activities of Sergei Vadeyev. We were in charge of bringing experiments and facilities, technological, scientific ones, to the Mir space station. And my man on board was Sergei Vadeyev, together with other two astronauts. And since then, we developed some skills in Europe that we are ready to bring to Mauritius. And we, with the Spaceland Africa program, we have a new company here in Mauritius these days. We will be actually selecting the first Mauritius astronauts, female and male, that could board with us for suborbital research flights. Because basically, what is Spaceland? Spaceland is a project that is dealing with research and development in microgravity. So wherever the gravity force is actually decreasing or zeroing itself, we have new opportunities to study whatever needs to be done to solve astronauts' problem, but also this can be applied to elderly people, people with disabilities, children. For instance, osteoporosis or bone demineralization or other cardiac or neuromuscular problems that astronauts face every day in microgravity, without gravity, are actually the same that elderly people experience on the ground. And the same for people bed resting after traumatic incidents, or children. Children have to develop their bones and the muscles and their cardiac muscles in a way that is similar to the problem that the astronauts are facing. So this project in Mauritius will definitely change the future of the country, because we are planning to have a space center here in synergy with local universities, and we want to create jobs and provide even the opportunity to have the first space shuttle land in Mauritius with the United Nations. So it could be really a breakthrough for the island. Spaceland has been working closely with the United Nations to look for an ideal landing platform in the ocean. And Mauritius has a perfect spaceport in principle by converting the current airport. The SSR airport is, we identified the airport as one of the best candidates for the United Nations first space flight. This flight will take off from Florida, from NASA, vertical on a rocket, and the space shuttle, a new space shuttle, could land in Mauritius because of the vicinity of the airport to the ocean. Because of the re-entry trajectory will not impact on the population. There will be no environmental impacts on the environment, on nature. And the economic and climatic stability of the country is very interesting to us. Now the choice is for Mauritius to really accelerate the decision-making process, because the United Nations is waiting for Spaceland to tell them this is the place. It's very likely that we will find a way to officially start this space economy in Mauritius. The Spaceland microgravity projects that we have are going to involve all the professionals that are currently going outside Mauritius. So we are also addressing the so-called Mauritius diaspora communities, because by studying with Spaceland at the Spaceland Center in synergy with local university, all these people, all the local citizens will not have to go abroad to look for a job, but they could basically just switch from university studies to a career into the Spaceland Center or into all the small and medium enterprises that are going to be involved with the Spaceland Center. Therefore, it will be a new way to attract professionals and a new way to stimulate youngsters to study and to have a perfect career in one of these disciplines. And by the way, flying into microgravity, flying into space is really cool. All the Mauritius youngsters will love it.
The work started a couple of decades ago, with Mauritius being placed on the map of research in astronomy with the building of the Mauritius Radio Telescope. Astronomy is today a well-established field of research in the country and has expanded into international cooperation with projects such as the Square Kilometre Array and the Kibo Cube. These are indeed exciting times for current and future generations, as they have the privilege and responsibility of going beyond the frontiers established by pioneers in the field and taking Mauritius onto the next level into space exploration.